Hello everyone, so today we're talking about segments and midpoints. We have two goals for today. Goal number one is I can use the segment addition postulate to solve for missing values. You can pre-rate yourself on that and how you feel about it. If you're like, I don't know what the segment addition postulate is, well then not obviously maybe, then I'd give yourself a 1, right? 1 meaning no clue. 2 being like, I think I know what that is. Let's see a problem. Can I try it? And 3 being like, I learned this. I know how to do it. Next, I can use the definition of a midpoint or a segment bisector to solve for missing values. If you're not sure what that means, I can fast forward here. Fast forward. Let's see where the midpoints are. Here we go. This problem right here. Okay, do you know do that? And I don't mean like, do you know that a midpoint means it's in the middle? I mean, can you solve that problem? Okay, if one's like, no, I don't know how. In most lessons, everyone's going to start off at a 1, right? Just so everyone feels a little bit better about that. Hopefully you get to a 3, but I need everyone to get to a 2. If you still feel like you're at a 1 after a lesson, that's when we need to talk. Okay, go ahead, pause the video. If you haven't sent this to Notability, you can pause the video and do that right now, but get the notes, send it to Notability, and practice these 2 problems to see what you get as answers. Okay? All right, so really quickly, I'm going to do the problems. If you need to watch me, you can. If not, you can fast forward a little. All right, so on the left-hand side, I see that I have like terms that I need to combine. 7x. No more like terms, so plus 2 equals. On the right side, there are no like terms, 44. All right, remember my whole goal is to get x by itself. So to get x by itself, first I have to undo that plus 2. So I'm going to subtract 2. And then to get rid of that 7, I need to divide by 7. And I get x equals 6. All right, next one right here, if I look at the left-hand side of the equation, there are no like terms. If I look at the right-hand side, there are no like terms. So I'm going to get all my x's on one side. I'm going to subtract 2x from both sides. I like to look at it and say, what's bigger, 2x or 4x? 4x is bigger, you get to stay. 2x, you got to leave. So now I have 16 is equal to 2x minus 8. Now I need to get the x by itself, so I'm going to add 8 to both sides. I have 24 equals 2x. And then finally divide by 2. X equals 12. If you're like, I did it a different way, I subtracted 4x from both sides first. If you still got 12 as an answer, you did it correctly. If you didn't get 12 as an answer, that's where your way didn't work. Okay, so quick notation intro. Okay, so these are just a few things that you need to know. Consider the segment below. We learned that in our last lesson. That's segment AB. If we're talking about the segment, we would write AB with the bar over it, like that in green right there. If we're talking about the length of the segment, we would write AB without segment. If I say, what's the length? You would say AB. You know, when I underline, I shouldn't be underlining because it looks like it needs one. You would say AB, the equal sign means is 7 centimeters, like it's labeled up there. When naming the object, you use the bar. When you're referring to the length, you do not use the bar. Okay, so object, use a bar, length, no bar. Okay, so the first few problems we're starting off with are super, super easy. I want to point that out. Okay, so if you're like, oh my God, this is so easy. It is. It is very easy. This one says, John is working on a paper route. Consider the following scenarios. Starting at house A, he walks 2 blocks east to house B. Then he walks 5 more blocks east to house C. How far is it from house A to house C? What's the answer? If you're saying the answer is 7, that is correct. The reason I did a problem so easy is that I want you to write this properly. So we would say AC equals 7, right? AC is 7, okay? Okay, so that brings us to the segment addition postulate, okay? So the segment addition postulate is a postulate that says, if I have a segment such as segment AC right here, I can get its length by adding the segments that are made up by it. So I can do this piece plus this piece. okay? So if B is between A and C, so this is drawn right here. So this is A, this is C. Notice right here that B is in between it. Okay, if B is between A and C, then AB, this length right here in red, maybe I should color code it to make it easier, right? AB plus this segment in blue right here, BC, is equal to the length of the whole entire segment, which is AC. Okay, and it should make sense right here. If you notice, like, these two match, right? That's where they meet up. So like the whole length is from beginning to end, AC. Okay, so I feel like it makes sense with how it's written, right? You'll see me do this a lot. Let me change colors here. It's just something different than these three. This piece plus this piece equals the whole thing. And it makes sense because if you add those two pieces together, you get the whole piece. Now, one thing that's really important is that you can only compare lengths if points are collinear. When I say the word between, it means that the points are collinear, okay? So when I say B is between A and C, I do not mean that B is between A and C right here. By using the word between, it means that they form a straight line and B is somewhere in between the points A and C. Okay, so this is not okay. Okay. Another easy one, find AC. So AC here, I just have to do 8 plus 3, which is 11. All right, make sure you're writing AC equals 11, not just writing 11. We want to be very proper in geometry. All right, next one, find XY. So I want to know what this length is here. So the most common incorrect answer I get when people are starting is X plus 2. Right? That's not an answer, right? That is not what we're looking for. That's an expression. I want to know exactly how long it is, okay? Also, please realize when you're reading this means find the length of XY. But just by writing this XY right here, that means the length of XY. Okay, so find the length of XY. All right, so I need to figure out what it is. Okay, so I need to write an equation that will help me solve for X. And then once I know what X is, I can plug it back in and figure out what XY is. Okay, so I always bring back to a nice easy one here. And if I said that this is 3 and this is 2, what's the whole thing? The answer is 5. And it's because this plus this is equal to this. All right, so in other words, this, which is X plus 2, plus this, which is 4X, is equal to the whole thing, which is 42. All right, now I have to solve this. This is why we started with that warm-up, okay? So on the left-hand side of the equation, all right, so here's my left-hand side of my equation. Do I have any like terms? Yes, oops. We have X and 4X, so I'm going to combine those. 5X. Do we have any other like terms? No. So plus 2 equals. Look on the right-hand side. Are there any like terms on the right-hand side? No, so I'm just going to write 42. All right, now I have to solve this two-step equation. To get rid of the plus 2, I'm going to subtract 2 from both sides of the equation. So now I have 5X, this is gone, equals 42 minus 2 is 40. Now I have 5 times X. To get rid of multiplication, I use division. So I'm going to divide both sides by 5, and I have X equals 8. Okay, now, I don't just box this answer. I never asked you what's X. I asked you what is the length of segment XY. So now that I know the length of segment XY, I'm going to plug in an 8 right here so I can figure it out. Okay, so I have XY is equal to 8 plus 2. Therefore, XY is 10. If you jump to just saying XY is 10, there's no problem with that. I know you can do 8 plus 2 in your head. Okay, so now we have additional practice here where the picture's not drawn for you. So this one says, find the measure of segment MN if N is between M and P, and then I give you a bunch of measurements, okay? So the first thing that you have to know is that N is between M and P. When you see that, you need to know what to do, okay? So when you see blank is between blank and blank, what you're gonna do is you're gonna draw a line segment, okay? You're gonna draw it, you're gonna draw a line segment. You're gonna put 3 points on it because there's 1, 2, 3 points. So 1, 2, 3 points. Notice I did not put this point in the middle because I don't want my brain to say, hey, it's definitely in the middle. I don't know if it's in the middle. It just says it's between. So it says N is between M and P. So the N does have to be the point that's in between the two endpoints. M and P could be switched if I wanted them to be. Okay, so now I'm going to label what they gave me. They gave me MN is 3x plus 2. So I'll label that piece 3x plus 2. NP is 18. And MP, the whole thing, so I'm going to go outside of it and label the whole thing 5x. All right, now it's very similar to the one that we just did. Okay, so why don't you pause the video, draw it yourself, make sure it matches up with mine, and then solve for x, and then find the measure of MN. Okay, I'm going to go through this really quickly here. If you have questions, you can ask me in the Zoom call. You can pause the video after you watch this and say, hey, can you re-explain that? And I will re-explain it to you. So it's this piece, MN, 3x plus 2, plus this piece, 18, is equal to the whole thing, 5x. All right, look at the left-hand side of the equation. Are there any like terms? 2 and 18. 3x plus 20 is equal to, if you look at the right-hand side, are there any like terms? No, 5x. All right, now I have to solve for x, and there's x's on both sides. So I have to say to myself, okay, I have to get them all on one side. What do I want to keep? Do I want to keep the 5x here or the 3x? I like to keep the bigger one, so I'm going to subtract 3x from both sides. 20 equals 2x. Divide both sides by 2. X is 10. All right, now that I know what x is, remember, I'm not going to box my answer and say I'm done. I'm going to go back and see what I need. The measure of MN. So MN is equal to, I got to plug in 10 right there. So I'm going to do 3 times 10 plus 2. MN is equal to 30 plus 2 is 32. And there's my answer. If you got 32, good job. Okay, next one. I want you to pause the video and once again, try this one all by yourself. When you come back, I'll start working on the problem. I'm just going to tell you answers. Okay? If you did not get this answer, then that's when I once again want you to go to the Zoom call and say, Mrs. Dellen, I didn't get blah, blah, blah. How did you get that? Can you tell me what I did wrong? Okay? Go ahead, pause the video, try it. All right, if you did this one correctly, I want to make sure it's drawn correctly. So H is in between. So here's H is in between G and D. Then it told me GH is 6x minus 5. And HD is 2x plus 3. And the whole thing, GD, is 30. So your equation should be this piece, 6x minus 5, plus this piece, 2x plus 3, is equal to the whole thing, which is 30. Okay, if you did this one correctly and you solved it correctly, you should have x is 4, and your final answer then is GH is 19. If you're not getting that, once again, pause the video, come meet me in Zoom, and say, hey, Mrs. Dellen, I'm not getting GH is 19. Can you look at my work? What am I doing wrong? Okay, next topic is midpoint and bisectors. Okay, so a midpoint, first off, is a point. Okay, it splits a segment into two smaller segments of equal length. So let's draw an example of what a midpoint looks like. Okay, so first off, I'm going to draw a segment. Now, let's call this segment AB. If I want to draw a midpoint, it's going to be directly in the middle. Okay? Now let's say I walked away, I got coffee, and I came back and I said, is that point in the middle or is it just in between? Without reading a sentence, how do I know? Okay? You don't. So what you have to do is you have to adjust your picture so you can tell that it's in the middle. To tell that it's in the middle, what we're going to do is we're going to mark this piece equal to this piece by giving it tick marks. So now by having those tick marks, I know that AM has the same length as MP. Okay? You'll also hear me use the word congruent. Congruent means that they are equal. Right now, AM is not congruent to MB. They are not equal because they have two different tick marks. But if I put the same amount of tick marks on each piece, they are now equal. Therefore, M is a midpoint. All right, next one is a segment bisector. Okay, so a segment bisector is a line, segment, or array. So the difference between these 2 points is that this is a point, this is a segment, line, or array. Okay, but it's going to go through the midpoint. So a segment bisector, bi, remember, means two, cutting into two pieces, is going to also give you two congruent segments. So let me show you the difference here. So what I'm going to do is I'm going to draw a segment AB, and I'm going to draw midpoint M, two congruent pieces. So now I know M is a midpoint. I have not drawn a segment bisector. A segment bisector is a line, segment, or ray that is going through the midpoint. So maybe this has a name JK right here. Okay, so line JK is the segment bisector. Okay, line JK is my segment bisector. All right, let's try some example problems here. If you notice, I have a few. We'll do 3 together. We'll do 4A and B together, and then I want you to pause the video and try 5 on your own and come back for answers. Just like before, if you have questions, please ask me in the Zoom call. Okay, this one says D is the midpoint of EF. It's the first thing I have to do. The answer is draw a picture. Here's EF. D is the midpoint. Now, some people will stop working right here and be like, that's done, and start labeling. No, it's not. This does not say D is the midpoint of EF. Tick marks tell me D is the midpoint of EF. All right, ED is 4x plus 6. DF is 7x minus 9. And it says find ED, DF, and EF. All of these things, okay? So first thing I want to ask you is, can I use the segment addition postulate? Can I say this piece plus this piece equals the whole thing? The answer is not for this problem, okay? Not for this problem. The reason I can't do it for this problem is because I don't know what this is, okay? So if I didn't know if these two tick marks weren't here, this problem would be not possible, okay? But those tick marks are there. What do those tick marks mean? It means that they're equal. It means that they're congruent. It means that they're the same. So since they are equal, I can set those two pieces equal to each other. Okay? All right, now I need to solve this. Left-hand side. Any like terms? No. Right-hand side. Any like terms? No. Need to solve for x. First, I need to get x on one side of the equation. So I'm going to subtract 4x from both sides because 7x is more. 6 equals 3x minus 9. Got to get rid of that minus 9. So I'm going to add 9 to both sides. 15 equals 3x. Divide by 3. X equals 5. All right, did I ask you for x? Nope. I asked you for ED, DF, and EF. So let's start with ED. I need to plug in 5 here. So 4 times 5 plus 6. So ED is 26. Next, I have DF. Now, there's always someone that says, well, isn't it 26 also? It should be, but I want to check by plugging in 5. If I don't get 26, that means I made an algebra mistake. So don't just, oh yeah, I know it is. It should be, but did you do it right is the real question. 7 times 5 minus 9. So 35 minus 9, 26. So now I know I did my algebra right. Last one, EF. Okay, so that's the whole thing. You might be saying to yourself, wait a minute, Mrs. Dillon, you just said we didn't know the whole thing. We didn't know it a few minutes ago. But now I know that this is 26 and this is 26. So can I get the whole thing? Yes, by adding 26 and 26. So 26 plus 26, EF. Or 26 times 2 is the same thing, is 52. Okay? All right, let's move on to the next one where we have a little bit confusing of a diagram. Okay, it's slightly confusing here. And I did say that we're going to do the last problem on your own, but let's have you do B on your own. We'll try to have you do B on your own. Okay, first off, let's make sure we mark this correctly together. So it says, in the figure below, EC bisects AD at C. So let's talk about this first. This is really important that you watch this. If you're zoning out right now because you're like, hey, Mrs. Dillon, this video is long, guess what? This part's the part that people struggle with the most. All right, so EC bisects AD. My question is which segment is being bisected? AD, right? I'm bisecting AD. So now go find AD. Where's AD? I'm going to highlight it in pink. AD, okay? So what that's saying is that AD is being bisected. It's being cut in half. What is it being cut in half as? This is your knife, okay? So EC is my knife. Here's my knife. Chop, okay? It is the knife. Let's put a little knife on it so you can see that it's, that looks like a toothbrush. But you know what I'm trying to say here, okay? That's the knife, and it is cutting. Okay, it is cutting AC into 2 congruent pieces. So what are your 2 congruent pieces? AC is one of your pieces. And I'm doing this in a way because it's hard to mark it with those other things on it. And my other congruent piece right here is CD. So those are my 2 congruent pieces, AB and CD. Another way that you can do it, oopsies, is you can go like this. Like you can say from A to C and give that 1 tick mark, right? And then you can just give CD your other tick mark. And hopefully that can let you see that those 2 pieces are the same. Okay, they also give us more information. EF bisects AC at B. Okay, so what's being bisected? Bisects AC. So AC is being bisected. So let's find AC. AC is this red piece right here. Okay, so it's saying AC is also being bisected. It's being cut into 2 congruent pieces. What's the knife? EF is the knife. So EF is chopping it. So chop it with EF. Here's the knife. Chop, 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 right? So you get 2 congruent pieces, AB and BC. Now I already used 1 tick mark, and I want to make sure that for this I'm using 2 tick marks or something different. Because if I use 1 tick mark again, then I'm saying CD, BC, and AB are all the same, which is not true. Okay, for each of the following, find the value of X and find the measure of each segment. Okay, so let's start with A, and then I'm going to have you pause the video and try B on your own. AB is 3X plus 6. So I'm going to switch colors here. I'm going to end up erasing this because when I get to part B, I'm going to use completely different information. AB, this one right here, 3X plus 6. BC, 2X plus 14. Find AC. Okay, so first off, always worry about finding X first. How can I find X with this given information? Well, if you look, they both have red tick marks. Okay, that means that those 2 pieces are congruent, which means they're equal. So to solve for X, I can set them equal to each other. All right, no like terms on the left, no like terms on the right. X is on each side, so I'm going to subtract 2X from both sides. I have x plus 6 equals 14. Subtract 6, x equals 8. All right, now it says find AC. AC is this whole entire piece here, okay? So I don't have that labeled with anything, but I have each individual piece labeled. So I'm going to find out what AB is first. 3 times 8 plus 6, which is 30. And then make sure BC is also 30. 2 times 8 plus 14, which is 30. So this is 30, and this is 30, right? So that means the whole thing is 30 plus 30, which is 60. So AC is 60. Okay, so now what I'm going to do is I'm going to go in and I'm going to erase everything blue because I'm not using that for the next problem. Go ahead and pause the video and try B on your own. Make sure you label. If you don't label, that's what confuses people. Okay, I'm going to do this in a completely different color. Let's do purple. Okay. AD is 6x minus 4. So where's AD? AD is this whole entire thing. 6x minus 4. AC is 4x minus 3. So AC is this green piece right here. 4x minus 3. Find CD. All right, first thing I have to do is I have to find x. So let's talk about things that people do wrong. One thing people say that is incorrect is, oh, I'm going to set them equal to each other. Really? That's like pretend AD, that whole thing is a candy bar. And I said, hey, I have this candy bar. Is half of it, right here, half of it, the same thing as the whole thing? No, it's not. It makes no sense. Okay? So you can't do that. Can't set those two equal to each other. But my question is there anything I can label this piece? Is there anything I can label this piece? The answer is yes, I can label it something. I can label it 4x minus 3. Why can I label it 4x minus 3? Because it's the exact same thing, exact same length as this piece right here. All right, so now what I can do is I can use the segment addition postulate to solve for x, because I know that this piece plus this piece equals the whole thing. Now, you might be asking yourself, why can't I just set these two equal to each other? If they're labeled with the exact same thing, everything's going to cancel out. You can't do that, okay? So instead I use the segment addition postulate. 4x minus 3 plus 4x minus 3 equals 6x minus 4. All right, left-hand side, are there any like terms? 4x and 4x is 8x. Negative 3 and negative 3 is negative 6. Equals 6x minus 4. Okay, notice there was no like terms on that side. All right, I need to get x's by themselves. They are not. So I'm going to get all these x's on this side by subtracting them. 2x minus 6 is equal to negative 4. Get rid of this negative 6 by adding 6 to both sides. 2x is equal to 2. Divide by 2. X is equal to 1. Okay, now I know x is 1, so I can finally find CD. Okay, so if you look, CD is this piece right here. So I'm going to plug it in there. CD is equal to 4 times 1 minus 3. CD is equal to 1. Okay? There's a few things that I'd be saying in class right now, like if you were there, and people bring up in class, so if you have them, please bring them up, but you shouldn't be writing like 4 times 1 minus 3, okay? We are in algebra, integrated algebra and geometry, and this means x. It doesn't mean times, okay? So make sure you're putting that in parentheses when you're showing that you're plugging things in. Okay, the very last problem. Now I said I keep going back and forth on how I want you to do this. Go ahead and pause the video. Try it on your own. Come back. Okay, so tricky situation with this. Hopefully you felt the tricky situation, but we'll see how you did. AB bisects CD. So I'm bisecting CD. Here's CD. I'm cutting it. The knife is AB. So the knife is AB. So I'm cutting this into 2 congruent pieces. The question is AB, are these two pieces congruent too? The answer is absolutely not, okay? I did not tell you that AB is bisected. I only told you CD is bisected, okay? Now I'm going to label. If AE is 3x plus 1 and BE is 5x minus 7, find the value of x, okay? So the number one thing people do wrong here is they force something to happen. In geometry, you cannot force things to happen. These two pieces, this piece and this piece, are not equal. They do not have tick marks. It is not bisected. I never said that E is the midpoint of AB. I never said AB was bisected. So I cannot set them equal to each other. I cannot do this piece plus this piece equals the whole thing because I don't know what the whole thing is. And if you're saying it's 8x minus 6 is the whole thing, you're going to have 8x minus 6 on the other side. Everything's going to cancel. It's not helpful. So how the heck am I going to find x? The thing is that you can't. This problem is not possible. Okay? CD is bisected, not AB. Okay? You have to get used to things not being possible. Are you ever going to take a test and a problem's not going to be possible? Absolutely. We are going to make sure that you're not forcing things to happen. Okay? So please remember that if the problem is not possible, don't force something to happen. Okay? But I also want to remind you that if you're doing your homework or taking a test and you're getting lots of problems that aren't possible, it's not right. You're doing something wrong. But if, one popped up and it's not possible, it isn't. Okay? All right. Go ahead and get started on the homework. If you have questions, go ahead and meet me in the Zoom.